Hey Algebra 1, and thanks for tuning in. Today we're going to be looking at Lesson 8.0, Part 1, and this is just an introduction to our Quadratics chapter. You do get 2 worksheets to help you with some guided notes today, so make sure you have those before you start taking notes on this, otherwise you'll just be writing down a lot more than needed. And let's go ahead and get started with that first study sheet. So this is a study sheet that you just got. And we're going to be talking about how that transforms from the parent function f of x is equal to x squared when we have it in vertex form, which is a times x minus h squared plus k, where a does not equal 0. And this is similar to that study sheet we got before, back in, what was that, chapter 3 or 4 with absolute values. For the first one, we're going to talk about what happens with this transformation. K is going to move the graph vertically. So if K is positive, the graph will shift up, but if K is negative, the graph will shift down. So what we're going to talk about is each transformation here and then sketch an example. For the first one, if we have x squared plus 3, that translation will be 3 units up. So when we sketch it on a graph, the graph would look something like this. If we have f of x is equal to x squared minus 4, that means we'll have a translation of 4 units down. And this is what that graph would look like. So just scooted 4 units down. Moving on to letter H. H is going to move the graph horizontally, and that's the way that you can remember it. So you want to think about K is your y values and H are your x values. If H is positive, the graph will shift right. But if H is negative, the graph will shift left. And remember, we need to kind of think backwards here. So in the first example, when we have f of x is equal to x minus 2 squared, that actually means that h is equal to 2. Remember, we're trying to plug in what minus 2 would get us back to 0, and that's a positive 2. So that's going to translate us 2 units to the right. So your parent function has just scooted 2 units to the right on your graph. For the next one though, h would be equal to negative 1 because we're thinking what plus 1 would get us back to 0. Since h is negative 1, we are going to translate 1 unit to the left. So this is what that looks like on the graph. So we'll scoot it over just 1. The last section we're going to talk about is A, and just what happens when A is varied. If A is positive, the graph will open upward, and the vertex is the minimum. If A is negative, though, the graph will open downward, and the vertex is the maximum. Just remember, if A is greater than 1, then the graph will stretch closer to the y-axis by a factor of A. But if A is in between 0 and 1, the graph will actually shrink closer to the x-axis by a factor of A. So we're going to talk about each individual one of these examples real quick. For f of x is equal to 2x squared, A is equal to 2. So that means they're going to be twice as narrow as the parent graph. And this is what that would look like. So it's going to shoot up twice as fast on your graph. If A is equal to 1/2, like in example 2, this one is going to be twice as wide as the parent graph, which would make it look like this, where we're coming up slowly and it's shrinking closer to the x-axis. The last example is when A would be equal to a negative number. So this one's A is equal to just a negative 1. What this is going to do to the graph is it's going to reflect across the x-axis or open downward. So this is what this will look like, where it would still be the parent graph, just open downward. 2 things to keep in mind at the very bottom. The vertex of each graph is the ordered pair h comma k. So whatever h is, comma k is. Remember, h is, you're always going to just choose the opposite number of whatever's in the parentheses with the f with the x. And then the axis of symmetry will always be whatever x or h is equal to. Now that we have our study sheet filled out, let's go ahead and move on to this table of values example, and we're going to try the first one on the first page, and then maybe talk about the ones on the back page too. So it says, first predict the transformation of each function, and then complete the table of values and graph the points to check your prediction. So we do have what we know is what's called vertex form and how that relates to all the different values of A and H and K. In number one, we should be able to make our prediction that the parabola is translated 1 unit to the right because H is equal to 1. We can also say that A is equal to a -1, which means my graph, once completed, should open downward. So what we're going to do now is go ahead and fill out the rest of the table to see where my points would be. Remember, your function is negative parentheses x minus 1 to the second power. So all you're going to do is just plug in your x values here. And then complete what that would equal to as the y. Let's go ahead and maybe pause here so you can finish filling out your table, and if you feel comfortable enough, go ahead and graph your points. Alright, so for when we plug in 3, that's essentially -2 squared with the negative still being there, so we're going to get -4. Number 2, we'll get -1. Number 1, we get 0. When we start plugging in 0, we're actually going to go back to a -1, and then when we plug in a -1, we're back to -4. So notice we have kind of a repetition over here. You do want to look for that every time you make a parabola or the parent function of vertex form. Now let's go ahead and graph these. So I've got 3, -4, 2, -1, and then 1, 0, and then it basically goes back down. 0, -1, and then -1, -4. And notice the points are symmetrical, and you just want to make sure that you curve your line once you're done. Okay? So that'd be how you would complete the second one as well. I'm going to let you try that one on your own, and we're going to talk about the back. So number 3, so you'll go back to number 2 for homework. But number 3, basically just asking, what is the vertex and the axis of symmetry? Really quickly, if you look at the bottom of your study sheet, the vertex is h, k, and the axis of symmetry is the vertical line where x is equal to h. So if we are trying this one, we want to make sure that our vertex is whatever h, k is, and then the axis of symmetry is x is equal to h, so x is equal to whatever that h number is. For this one, I'm going to go ahead and just label A, H, and K. A is not equal to anything, or we're going to say 1. H is equal to a +8, and K is equal to 0. So that means my vertex, h, k, is 8, 0, and my axis of symmetry is x is equal to h, which would be x is equal to 8. So these would be my 2 answers for number 3, and that gives you an idea of how to answer number 4. That's going to conclude our notes for today. So I've kind of given you a taste of how everything is going to work. You're going to complete the tables and values worksheet front and back all the way to number 10 for homework. And tomorrow we'll learn more about the vocabulary terms of parabolas. Thanks so much for tuning in, and we'll catch you next time.